Alright guys, let's take a look at some homework tonight, okay? We are on lesson 5.4. We're working with the focus and the directrix of a parabola. For the regular classes, you had to do all the odds. For the advanced classes, you were able to omit numbers 2, 5, 6, 7, 12, 15, 16, 22, 23, and 25. Okay, so that gave, I think, 13 problems for the regular kids and 15 for the advanced, I believe. All right. Let's start with number 1. Number 1 says, write an equation of a parabola with vertex at the origin and the given focus. All right, I want to take a look at what this looks like first, okay? We have a vertex at the origin. We have a focus at -2, 0, okay? If I kind of sketched out the parabola, it would look something like this. Remember that the focus is on the inside of the parabola. Okay, now this is a horizontal parabola. Okay, now we said this focus. Okay, focus is -2, 0. Remember that the focus is C0. Okay, our number is in the X position because it moved to the left. Okay, and the Y remains 0 because our vertex is at our origin. So our axis of symmetry is y equals 0, so that would be our 0. Now, -2, 0 is our focus. That means C is equal to -2. Okay? All right. Now, because this is a horizontal equation, my equation is going to start with x equals. Okay? So this is x equals 1 over 4c y squared. Okay? And then I'm going to plug c in, or no, -2 in for c. So 1 over 4 times -2 y squared. Multiply my 4 times -2. That gives me 1 over -8 y squared. And there's my answer. Okay? That's actually pretty painless. Okay? Let's go take a look at, I think we're doing number 3 next. All right, number 3. We've got a vertex at the origin. And then we have a focus at 0, -3. Okay. Now, sketch out our graph there. And we have a vertical graph that opens down. Remember, it wraps around the focus. So, this is a vertical parabola. Okay, vertical parabolas means I have my change in the y part of my coordinate pair. So my focus is going to be 0c. Okay, and my focus is 0, -3. Therefore, c is equal to -3. Okay? Now, again, we have a vertical So this means I have a y equals, oops, let me erase that. A y equals 1 over 4c x squared for my equation. I'm going to plug -3 in for c. Okay, multiply those together, and I get y is equal to -1/12 x squared. Okay, again, pretty painless. All right, let's look at number 9. Number 9 is y equals 1/12 x minus 1 squared. And my directions say to identify the vertex, the focus, and the directrix of the parabola with the given equation. And then we're going to sketch the graph of the parabola. Okay, first thing, let's get our graph kind of sketched out there. Okay. Now, my vertex, if we look here, remember H and K give us our vertex. So 1 is in my H position, and I have nothing in my K position. So my vertex is 1, 0, right? All right. So 1, 0. You can see that down here on the graph. Okay. Now, A is equal to 1 over 4c, right? In our equation, A is equal to 1 over 12. Now, I need to figure out what c is. So I'm going to take and set 1 over 4c equal to 1 over 12. Okay? And then to find c, I'm going to go about and do my cross multiply. Okay? So we end up with 12 is equal to 4c. I'm going to divide by 4. And I get c is equal to 3. Okay? So now I know my c. And that's going to help me find my focus and my directrix. Okay? Alrighty. Let's think about this first. Focus is H with C, excuse me, I got the hiccups all of a sudden, with C as my my focal point, my focal length, right? Okay. And then my directrix, okay, and remember this is y equals, so this is a vertical equation or vertical graph. So my directrix is also going to be y equals. So y equals for the directrix is -c. Remember that? Okay. So now remember that it changes vertically, so we see the change happen in the y value of our coordinate pair. The h in our focus is going to be the same h as in our vertex because it's on the same axis of symmetry. So my focus for the x is 1, and then the 3 for C is my K. So my focus is now at 1, 3. Okay? My directrix is y equals -c. So my directrix is y is equal to -c, which is let's see, did I write that in there? I did not. Y is equal to -3. I'll write that in there here in just a second. Let me go back here. Okay, back up just a smidge. Okay, directrix is y equals -c. And we'll write that out in a minute. I don't want to mess up what I've got here. So I'm going to graph real quick, and when I get finished, I'll fix my directrix. My focus is at 1, 3. Okay, that's that green dot there. And then my directrix is y equals -3. So there's the line of my directrix, right? Okay. Now, I know that I have a rate of change at 1/12. So I go up 1/12 and up 1/12. That gives me my first rate points for my rate of change. And graph out my graph. There we go. Okay. Now, okay. All right, now let me fix that over here. And we will fix this. So my directrix is equal to -3. There we go. So we have a vertex at 1, 0. We have a focus at 1, 3. We have a directrix at y equals -3. And our graph looks like this down here at the bottom. All right. Sorry I got that mixed up on the directrix a while ago. All right. Next problem. All right, my next section says write an equation of a parabola with a vertex at the origin and the given directrix. Okay, we're going to look at two problems here. One is for the regular. Actually, it's for both regular and advanced. The other is just for advanced, but it's good for you in the regular class to see it as well. And I'll explain why as I go along. All right, number 11. Okay, number 11 says we have a vertex at 0, 0. And we have a directrix at x equals, oops. Oh no, I just messed that up. Okay, we will have to work these out then. Okay, so I've got a directrix at x equals 3. Let me change that color back. There we go. X equals 3. Okay, now I have my directrix is x equals -c, right? Make that a better c. X equals -c. So if I set those equal to each other, I have -c is equal to 3. I want positive c, so I'm going to divide it by -1. And c is equal to -3. Okay? Now, I'm going to put that into our equation. And I have an x equals, so that is a horizontal graph. So I'm going to start my equation with x equals. So x equals 1/4c y squared. Substitute -3 for c. So x equals 1/4 times -3 y squared. Multiply those together, I get x is equal to -1/12 y squared. And there's our final answer. Okay? Alrighty. Let's do, this is the one that I'm going to do for the advanced, but it's good for y'all to see it as well for the regular classes. Because now instead of an x equaled for a horizontal, I have y equals -3 for my directrix, which gives me a vertical graph. So, number 14, I have a vertex at, oops, go away, at 0, 0. I have a Directrix at, oops, clean that all up. Directrix is at y equals -3. Okay, again, my Directrix is y equals -c. Set those equal to each other. -c equals -3. I'll divide by -1. And c is equal to 3. Okay. Again, we had y equals as my Directrix. So y equals is going to be the equation that I use. So y equals 1 over 4c x squared. Substitute the 3 for c. Y is 1 over 4 times 3 x squared. Multiply that out, and we get y is equal to 1/12 x squared. All right? And we're done with that. Hopefully that didn't go too fast for you. Okay? As always, if you have questions, please either make comments on the video or text me at 254-592-5547 and let me know that you are having a problem, and I will help walk you through it if you're still having difficulties. Okay, let's go to our next equation. Okay, sorry about that. I had not backed off my my writings so I could walk you through it. So we've got it cleared up now. All right, number 19. No, I did not go over number 17. We'll go over that one together in class tomorrow. I'm getting short on time. I need to get free so that I can go take care of some stuff here in just a little bit. But I wanted to get finished with this video before I went to take care of my business. Number 19. It says, write an equation for a parabola with the given parameters, then graph the parabola. Okay? So, number 19, we have a focus at 0, 1. We have a Directrix at x equals -2. Remember, all we have here is the focus and the Directrix. We don't have the vertex. We don't have any point on the graph. Okay? So, the only thing we know for sure is that any point on that graph is going to be the equal distance to the focus as it is to the Directrix. Therefore, since we know that we are looking at distance or length, we are going to use the distance formula. Okay? Remember that my focus is my x1 and y1. My Directrix is my x2. And essentially is my y2 as well. Since I don't have a y, we're just going to substitute y for y2. Okay. Let's work this out. Start out, square root, and I'm going to have x minus x1, which is 0, squared, plus y minus 1 squared, which is y1, is equal to the square root of x minus -2 squared, tick, tick, remember? So, okay, now, we've got the square roots on both sides. Before I go on, I want to go ahead and take care of my square roots. I want to get rid of those so that I'm working strictly with my equations. I can do that by squaring both sides. And when I square both sides, that eliminates the radical and the exponents on both. That leaves me with x squared minus, or not minus, but just x squared, because x minus 0 is x. So we have x squared plus y minus 1 squared is equal to x plus 2 squared. Okay, and then remember, y minus y is 0, so we don't have to put that down. Alrighty. Now, remember, we are working with, because we have a directrix of x equals negative 2, that means I'm working with a horizontal graph, right? So, in that horizontal graph, horizontal equation, we have y minus k squared. And so we want to keep this y minus 1 squared, we want to keep that exactly as it is. Okay, we're going to expand our x's, okay? And one of the things to remember is that whichever variable you have 2 of, that's the ones you're going to expand. The one that you have 1 of, that's the one you're going to leave it alone. Okay? All right, so on the left side, we have x squared. Okay? Nothing's going to happen with that. It's just x squared. And then we have plus y minus 1 squared. Okay? And that equals, now we're going to expand out the binomial x plus 2 squared. And like I say, you could do that in the FOIL method. You could use your Punnett squares if that's what you wanted to do. You could use our shortcut, which is a squared, excuse me, my voice just cracked. A squared plus 2 times a times b plus b squared. And that's what I'm going to do. Okay, we're going to first take the first term and square it, so I get x squared. And then I'm going to take the first term and the second term, x and 2, multiply those together. That gives me 2x. I'm going to multiply that by 2. That gives me 4x. All right, and then my b squared in the last part of that is the second term squared, so I get 2 times 2, which is 4. Rachel, would you give me a glass of water, please? My throat's drying out. Oh, wait, I've got something. But I do need some fresh water. Would you please? All right. Now, like I say, we're going to leave the y minus 1 squared alone. But I need to move that x squared from the left-hand side over to the right-hand side. So I'm going to do that by subtracting. So I'm going to subtract x squared from both sides. Okay? And that's all I've got to move over. So now what am I left with? I am left with y minus 1 squared is equal to 4x plus 4. Okay? And I look at my 4x plus 4 and I say, what can I factor out? I can factor out a 4. Okay? When I factor out that 4, I factor out that 4 from both terms in that binomial. And somebody asked earlier, why don't I factor it out when I factor it out, why doesn't it go away? Well, because I'm only factoring it out on one side. I'm not factoring it out on the other side yet. So I'm not dividing both sides by 4. Okay, I'm only dividing the terms in that binomial by 4. So what I end up left with is y minus 1 squared is equal to 4 times 4x divided by 4 is x, and then 4 divided by 4 is 1, so we have plus 1. Oh, thank you. Hey, Rachel. What? Y'all get ready to go up to the church in a minute. All right. Now that I have that 4 factored out, now I'm going to reduce it from both sides. Remember that we are imagining a 1 on the y side. So I'm dividing each side by 4. Okay? That's going to leave me with 1/4 times y minus 1 squared is equal to x plus 1. Okay? Now, I want to move that 1 over to the other side, so I'm going to subtract 1 from both sides, and I end up with 1/4 y minus 1 squared minus 1. Okay? And I didn't write that negative 1 over there on minus 1 on the other side, but you get the point. Now, we've got to graph it, right? Okay. Get a graph up here. Now, what's my vertex? I look at this equation. X equals 1/4 times y minus k squared minus 1, right? So, I've got to look at my equation. I have minus y minus k, so that means k is positive. Okay. K is positive, so my vertex, oops, wrong pen. Let's just do it in that color, that's fine. My vertex is at, my K is positive 1. My H is negative 1. Okay, sorry, I got interrupted and had to stop the video for a second. I think this might be where I was. If not, I backed up just a little bit to make sure that I knew exactly where we were at. Now, my vertex. We determined that my vertex, the H was negative 1. Remember, H and K are switched because this is horizontal, not vertical. Okay, so my negative 1 is my H. That's the X in my vertex. And 1 is my K. Positive 1 is my K. So that is my Y in my vertex. So negative 1, 1 is my my vertex. Now, let's figure out a little T-chart real quick of 3 points. Okay? So we have Y and X. Why did I reverse them? Because this is horizontal. So Y is the independent variable, and X is the dependent. So whatever Y is determines what X is. Remember, it's backwards. So we have our vertex. Remember, X is negative 1, so we have to put that in the X column. The Y is 1, that's our independent variable, so that goes into the Y column. Right now, so what if Y is 3? When I put Y in for 3, or 3 in for Y, 3 minus 1 is 2. 2 squared is 4. 4 divided by, or times 1/4, or divided by 4 is 1. And then 1 minus 1 is 0. Right? Okay? And then let's look at the other point. We're going to go to negative 1. Negative 1 for Y. Negative 1 minus 1 is negative 2. Squared is 4. Times 1/4 is 1. Minus 1, again, gave us 0. So we have points at 3, 0, and negative 1, 0. Sketch out that graph, and there you go. There's our positive horizontal graph. Alrighty? That's all we do for number 19. Let's move on. Alrighty. We've got 2 last problems we're going to do. In the last section, it says, write an equation of a parabola with the given vertex and focus. Alright, so let's look at number 21. Okay, number 21, we have a vertex at 0, 0. And we have a focus at 0, 4. Okay, now we look at this and we have the change in our y. Okay, that means if there's a change in the y, change in y means that we have a vertical graph. Okay, now that means up here we're going to have my vertex is h plus k, and then my focus, my h stays the same, but my k is where I add that c to, that focal length. Now, I need to figure out what my c is, right? And the change is in that k position, so I'm going to take 4. I'm going to subtract 0 from it. Let's clean that up a little bit. 4 minus 0. So I have a c, or a focal length, of 4. Okay, so I'm going to now plug that into my equation. I do have a vertical graph, so y equals 1 over 4cx squared is the format that I am using. And I'm going to take my c, my 4, and I'm going to plug it in. So I have y equals 1 over 4 times 4 x squared. Multiply that together and I get y is equal to 1/16 x squared. And voila, there is my graph. My equation. Excuse me. Okay, and it's that simple. Just find your c and then plug it in. Okay, now let's do number 25 because it's a little different. And we want to make sure that you're understanding what we're doing on when I have a vertex not at the origin. Okay, so number 25. Number 25, I have the vertex at 2, 9. 2, 9. My focus is at 3, 9. Okay? Now, my change, we can see, is in the x position. So if there is a change in the x in my vertex, in between my vertex and my focus, that means we have a horizontal graph. Okay? Horizontal graph. Now let's look at the change. Let's look at the focal length. So c is 3 minus 2, or 1. So I have a focal length of 1. Okay, now I'm going to use, since this is a horizontal graph, I'm going to use x is equal to 1 over 4c times y minus k squared plus h. Why did I write it all out? Because my vertex at 0, 0 in number 21 meant that I didn't have an h and a k to put in there, so I could use the condensed version. On number 25, my vertex is not at the origin, so I actually have an h and a k. So we need to make sure that we take care of those. Okay, so we have a focal length of 1. So we're going to plug 1 in. So we have x is equal to 1 over 4 times 1 times y minus my k in my vertex. My k in my vertex here, okay, is 9 squared plus my h in my vertex right here is 2. Okay, multiply that all out. We have x is equal to 1 over 4 times y minus 9 squared plus 2. And that's my final answer. All right, guys. Sorry that it's just a few minutes after 9. So we're going to get this stopped and saved so I can get it posted onto YouTube, and you'll see it on Facebook in just a few minutes. Thanks. Have a great night, and I'll see you tomorrow.